All right, so who can talk to me about Zach? Who can give me an idea? Zach says, I got 6n plus 1 because I noticed that 6 blocks were added each time, so the pattern must have started with 1 block at n equals 0. Who can explain Zach's method to me? Who can tell me how does he come up with this? Because he's talking about n equals 0. Well, we don't have n equals 0 because that would be like our XY chart, right? We don't have a 0. We only have 1, 2, and 3. We don't have 1 there. But how many blocks? Sorry, let me scoot that up so you can see it. How many blocks are in the first figure? Somebody tell me. 7. How many are in the second figure? 13. And in the third figure? 19. Okay. What did I highlight there on the pictures? Does anybody know what I highlighted there? Why did I highlight? The boxes that are being added. And I can see that here I have 1, 2, 3, 4, 5, 6 being added there. And 1, 2, 3, 4, 5, 6 being added there. So I had plus 6 and I had plus 6. Yeah? We good with that? How many are in the original one? I have 7 there, don't I? So how does he get his equation? He says that you take 6 and you multiply it by the term number. So in other words, 6 times 1 plus 1 gives me 7. Is that true? Okay. What about 6 times 2 is 12 plus 1 is 13? How does he get 6 times n, though? I'm wondering. Well, each time we're adding 6, right? So if I think about just the highlighted boxes, that is 6 boxes total, right? If I looked over here and I included both the 6 boxes being added and 7, 8, 9, 10, 11, 12, isn't that technically the ones that I filled in there? Aren't those the ones that were added in this one? Like the second one up there, that was the one that was added here. In other words, if I took off the highlighted ones there, the ones that I filled in are the highlighted ones from the previous one. Does that make sense? So I could think about, okay, well, the 6 that were added in the previous one and another 6, in other words, 6 times 2, that's where my 6 comes from. So each time I could say, even though we're adding another 6, it's really 6 times, well, if this is the third term, I'm multiplying it by 1 less than 3. So if I wanted to find the 7th term, let's say my table continued, he says that I would have 6 times 7, which is what? 42 plus 1. He's saying 43. Okay, I kind of get that. What about Sion? Can anybody tell me anything about her? Anybody? So she has a similar idea. She's saying that in the first one, there were 7 blocks, which we already identified, right? That's where she gets the plus 7 from. This right here is kind of what I just explained right here, right? 6 times n minus 1. Why does she have a different equation than him? Well, she looked at the problem a little bit differently, so she came to a different conclusion. But how are Zach's equation and Sion's equation, why are they different Or who's correct? Maybe that's a better way of asking it. Who's correct between the two? We have Zach and we have Sion. Who's correct? Any of them? Are either of them correct? How could they both be correct if they don't look the same? Any suggestions? Okay, one seems more recursive and one seems more explicit. Okay, is there anything we could do to them to like investigate a little further? Check them how? Okay, so you could plug in like 3 for n and see if you get 19 out. Is that what you're saying? Mm-hmm. So let's see. 3 minus 1 is 2 times 6 is 12 plus 7, that's 19. That works there. 6 times 3 is 18 plus 1 is 19. I'm curious, if I were to distribute this, what do I get? What the heck did I just do there? I just simplified it, right? And when you simplify it, you recognize that they're the same actual equation. So, what I want you to note here is that equations can look different originally because depending on how you see something, you may come up with the equation differently, but they can simplify to the same thing. So, equations can look different, but at their core, when they're all simplified, they really represent the same thing. Okay. That's one thing I hope that we've been learning through all of these things that we've been doing is that there are multiple ways that things can look and still be correct. Okay. It all has to do with how they're simplified. Okay. All right. Turn the page. Go ahead and answer number 1 on your own. I'll give you a minute to do that. Okay. The next problem Zach and Sion worked on was to write an equation of this line shown in the graph below. Okay, so here's our graph. When they were finished, here's the conversation they had. Sion said it was hard for me to tell where the graph crossed the y-axis. And looking right there, I can understand what she's saying. I know it's kind of hard for me to zoom in here. But it doesn't look like it's crossing at -2 or at -3. It looks like it's crossing between there. And if it's crossing between, I have no idea where it's crossing. I don't know if it's at -2.5, 2.6, 2.7. I have no clue where it's crossing. So I understand why she says it's hard to tell where it crosses the y-axis. So she found 2 points that she could read easily. -9, 2, and -15, 5. Because those ones cross grid lines, right? She figured the slope was -1/2. Well, let's count the slope to make sure she's correct here. I have 1, 2, 3 down. So yes, that would be negative. And then right 1, 2, 3, 4, 5, 6. So negative 3 over 6 is my rise over run. Does that simplify to negative 1/2? Yeah, so she's good there. So we've checked that. She made a table and checked it against the graph. So negative 15, 5. So negative 13 would be 4. Okay, I get that. Sorry, negative 13, 4. Negative 11, 3. It looks like she's got a lot of points that are on there, right? Negative 9, 2. So she says negative 1/2 n plus 9 plus 2. What form is this? Does anyone remember? Remember this? That's slope-intercept form. So she put in the slope that she has, and then she put in the point negative 9, positive 2, which was one of the 2 points that she got. So that makes sense as to how she got that. Okay, let me turn the page here. She was surprised to notice that the pattern was to start with n, add 9, multiply the slope, then add 2. She got this equation. And again, this is called point slope form because it gives the point and the slope. That's why it's called point slope. Now, Zach did something similar, but he used the points 7, negative 6 and 9, negative 7. And his equation is kind of different. One of us must be wrong because it says that you add 9 to the n value or the x value, and his says that you subtract. Which is it? Add 9 or subtract 9? How can we both be right? How could I check to see if they're both right? What did I do in the last one to check to see if they were the same? I did that, yes, but then after that, what did I do? I simplified, right? Got rid of those parentheses. So I'm curious, even though this one says a plus 9 and this one says a minus 9, let's do some simplifying and see what happens. So I'm going to start with Siones. Okay. F of x just means the same thing as y, right? F of x is equal to negative 1/2 parentheses x plus 9 plus 2. And I'm going to use my calculator because I have some fractions here. Not super comfortable with fractions, so let's see what we get. Negative 1/2 times x is negative 1/2 x, and negative 1/2 times 9, negative 1. Again, use that fraction button. That means negative 1/2. It's got that little like corner thing there. Times 9 is negative 4.5. I want to stick with mixed numbers. I'm sorry, improper fractions. So I have minus 9/2 and then plus 2. And again, I'm going to use my calculator's fraction button so that I don't have to stress about it. Negative 1/2 x, and I just need to add these two things together. Negative 9/2 plus 2. Second fraction button keeps it in a good form. Negative 5 over 2. So f of x is equal to. This is what hers simplifies to. Okay. Now let's check with Zach's. F of x equals negative 1/2 parentheses x minus 9 minus 7. Okay. So f of x equals negative 1/2 times x is negative 1/2 x. And negative 1/2 times negative 9 is going to be a positive, isn't it? Negative 1/2 times negative 9 should be the same as the other one, just the opposite sign, plus 9/2. And then I have my minus 7. So let's see. Negative 1/2 x. And I'm going to take 9/2 and I'm going to subtract 7. Change it to an improper fraction. Are they the same? Whoa. So he used different points. Let me go see what points those are. 7, -6. 7, -6. And 9, -7. So he used ones over here. But he could hopefully pretty well see that that's a -1/2 slope. Yeah? Do you think it matters? Because I got the same equation there with both of those. Do you think it would matter if I picked points in here? It doesn't matter. So point slope form is a little tricky just because there's a lot of different ways it could look depending on which points you choose to use. But at the end, once you simplify both of them, they both simplify to the same thing. So they're both representing the same line. Okay. So again, another way of saying they don't have to look identical as long as they simplify to something identical. Okay. Does that kind of make sense? Okay, that's all I'm going to do for the 2.5 out of the book or out of the packet. I'm going to skip the remainder of that, but I do want to, I have some other notes we're going to do. Okay. So don't run away from me yet. I do want to talk about your homework since I have it out here. You're going to go ahead and do the whole ready part. Okay. The ready part should be good to go, 1 through 9. The set part, I want you to skip the set part. Okay. So skip those 4 problems with the grid. Then when you get to the go part, you should be good again. Just skip this last one, number 20. So, excuse me, you're going to do the ready part and then 14 to 19 on go. Okay. I had somebody email me and say, is that extra credit if I do the part that I crossed out? No, it's not extra credit. It's just going to confuse you. Don't worry about it. Okay. All right. So let me go to the second part of the notes. So you can write this down on just a piece of lined paper if you want to. No big deal. Should go pretty quick. This is just to help you with your ready, set, go part. Okay. So if I gave you information, if I gave you a slope and a y-intercept, it should be pretty easy to write an equation in y equals mx plus b form, shouldn't it? Because I would just do y equals mx plus b. These problems should take you 2 seconds, right? What's number 2 going to look? Y equals, what's this going to look like? Y equals 3/5 x. And I don't do plus -2. I'm just going to do -2. Okay. Why don't you go ahead and finish up to number 6? Okay. Take a minute and finish up to number 6. Should be super easy. Is that what you got for number 3? Easy, right? How do I write 1x? I just write it like that. What about a b value of 0? And an m value of -1? Well, -1 times x is just -x. And if b is 0, I don't have to write it. I don't have to write plus 0 at the end. What does plus 0 do? It doesn't do anything, does it? What about if my slope is 0? Let's think about this for a minute. 0x plus 3. What is 0 times x? 0 times anything is just 0, right? So that actually drops out, and my equation is just y equals 3. When I get a situation like that, I have a line that is perfectly horizontal. No slope. It goes up 0 and over 1. My rise over run is 0 over 1. Okay? All right, let's do point slope form. Okay? We learned this last week, right? So y equals, I start off with my slope again. So in this case, I'll have 7. And then I will have x minus x1. X minus, there's my x1. I'll simplify that in a minute because I really don't need minus 0, right? And then I'll do plus y1. Well, that's a minus 5, so it's going to stay as a minus 5. So what does this end up looking like? What is x minus 0? Isn't anything minus 0 just itself? So it's just going to end up being 7x. And then minus 5. So this one's interesting because when you simplify it, it looks exactly the same as this form, doesn't it? Even though technically we wrote it in point slope form. Okay, let's do this one. I don't know what the slope is. What do I do? Slope formula. So 8 minus negative 4 over negative 2 minus 2. So this becomes 8 plus 4. On the bottom, I get negative 4. So let's see, 12 over negative 4. What's my slope? Negative 3. So which point should I use? Y equals negative 3. Which point should I use when I'm writing point slope form? It doesn't matter. I'm just going to start with the first one. So x, that's a positive 2. It needs to look like a minus 2 when we put it in parentheses. And then the minus 4 can stay as is. Now again, this is just an unsimplified version of y equals mx plus b. Okay? It says write a second equation for number 8. How can I write a second equation? Well, instead of using 2, negative 4, I could use negative 2, 8. So same slope, but this time I'm going to put x not minus 2, but plus 2, and then plus 8 outside of my parentheses. Okay. Next, it says show that these two equations represent the same line because it was from the same information, right? How can I represent that they show the same line? Anybody? There's number 8. Here's number 9. What do we do when we want the equations to look the same? Simplify them. Yep. So y equals negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. And then I have minus 4. So let's see, negative 3x plus 2. And let's see if this guy, I'm going to box that because that's what it simplifies to. This one, let's see, negative 3 times x is negative 3x. Negative 3 times positive 2 is negative 6. And then I have plus 8. Negative 3x plus 2. So when I simplify them both, they simplify to the same thing. And that's my proof that they really are the same equation. Okay. So, little bit more, just a little bit more. Equivalent equations is kind of what we talked about before, or is kind of what we've been talking about here. Equations that have identical solutions. To show two equations are equivalent, you can simplify to show that they're the same. Okay, so this is just like the go part on your homework. You need to prove that these two equations are equivalent because you need to simplify to show that they're the same. So this one right here, I don't think I can simplify that any further, can I? No. So I'm going to draw my little line through my equal sign so I make sure that I keep everything on one side. And this is the side that's got some craziness to simplify, right? And hopefully it's going to end up simplifying to 6 minus 13x. So let's see what we've got. Let me give you a second to write down that problem because I forgot you don't have this printed. Okay. What do you think I need to do first on this side to simplify? Anybody? The parentheses. So I am going to do what to get rid of the parentheses? Distribute, right? Negative 10 times 2x would be negative 20x. And then negative 10 times positive 8 would be negative 80. And then I still have plus 62 and plus 7x. Now, on this side, remember, because my goal is just to get both sides to equal the same thing. On this side, the number without the x comes first. So let's combine all the numbers that don't have an x first. That's all of them, right? So let's see. 24 minus 80 plus 62 is 6. Ooh, that looks good so far, doesn't it? Because it matches there. Now let's see what happens when I take negative 20x and plus 7x. Does it match what was on this side if I just bring this down? Yep. Now, it does say justify each step. So here's what I want to see when I say justify each step. How did I get from here to here? The first thing I did was I distributed, right? That was what got rid of the parentheses. And then how did I get from here to here? All I did was combine like terms. And that's pretty much most of the time when we're simplifying, we're just distributing and then we're combining like terms. Distribute, combine like terms. Distribute, combine like terms. Okay. Now, out of curiosity, what if I had a parentheses over here? Could I simplify this side also if I needed to? And as long as both simplify to the same thing, then I really have what I just did over here, right? So I could simplify both sides if I needed to, okay? So let's try this next one. X plus 3 equals 6 parentheses x plus 3 minus 5 parentheses x plus 3. Interesting, both parentheses are the same, aren't they? Well, let's distribute. 6 times x is 6x. 6 times 3 is 18. Negative 5 times x is negative 5x. And negative 5 times positive 3 is negative 15. Now, I want it to match the other side exactly. So they have the x term first. So I'm going to combine my x's first this time. Okay. 6x minus 5x, that's just plain old x, right? And what do I have when I have positive 18 and negative 15? I have positive 3. Isn't that what I needed it to be? And again, what did I do? Distribute. That's how I got from the first step to the second step. And how did I get from the second to the third? I combined like terms. Okay. All right. Last one I'd like you to try. Number 13. Last problem of the day. X minus 12 equals 8x minus 3 parentheses x plus 4, close your parentheses, minus 4x. Okay, so let me finish this last problem up here. So I have 8x, and then I'm going to distribute this negative 3. So negative 3 times x is negative 3x. Negative 3 times positive 4 is negative 12. And then I also have minus 4x. Okay. So they have the x first. So I'm going to combine all my x's. 8x minus 3x is 5x. Minus 4x is 1x. And then I have my minus 12. Does that equal what I needed it to equal? Yep, that looks good. So what are my reasons? What did I do first? Distribute. And after that, combine like terms. Okay.